Welcome to another video. Today we're going to be going over USACO 2015 December contest, the bronze division, and problem number 2, speeding ticket. So let's get into it. So Bessie the cow has stolen Farmer John's tractor and she's driving down a road. The road is exactly 100 miles long and Bessie drives the entire length before ultimately being pulled over by a police officer who gives a ticket to Bessie for exceeding the speed limit and having an expired license and operating a motor vehicle while being a cow. Bessie concedes that the last 2 tickets are probably valid, but she questions whether the police officer was correct in issuing the speeding ticket and wants to determine if she has indeed driven faster than the speed limit for part of her journey. So this road, the one that's 100 miles long, is divided into n segments, and each is described by a positive integer length in miles as well as an integer speed limit in the range 1 to 100 miles per hour. That might seem like a bunch of gibberish, but we'll get into it later. So because the road is 100 miles long, all lengths of n segments add up to 100. For example, the road might start with a segment of 45 miles with the speed limit 70, and then it might end with a segment of 55 miles with the speed limit of 60. Bessie's journey can also be described as a series of segments, m of them. During each segment, she travels for a certain positive integer number of miles at a certain integer speed. For example, she might begin by traveling 50 miles at speed 65, then another 50 miles at speed 55. The lengths of all m segments will eventually add up to 100 total miles. Farmer John's tractor can drive 100 miles per hour at its fastest. So given the information above, we need to determine the maximum amount over the speed limit that Bessie travels during any part of her journey. So for example, if the speed limit was 60 miles per hour and she drove 65, and that's the most that she went over the speed limit, we would return 5 because she drives 5 miles over the speed limit at most. So in our input, in the first line, we're given n and m, separated by a space. And so the next n lines will contain 2 integers describing a road segment, giving its length and its speed limit. And the next m lines will contain 2 integers describing a segment in Bessie's journey, giving the length and also the speed at which Bessie is moving. So in other words, if we have n and m here, n will give us the segment length and the speed limit for that segment. So our first segment on the road is 40 miles and the speed limit for that segment is 75 miles per hour, so on and so on. And then this is the segment that Bessie drives along with the speed that Bessie drove at for all 3 of these lines, because remember, n and m are both 3 and we have 6 segments here, so the first 3 are n and the last 3 are m. So we want to output a single line containing the maximum amount over the speed limit Bessie drove during any part of her journey. If she never exceeds the speed limit, output 0. So this is our sample input and our sample output. So let's go ahead and visualize this. So let's try and visualize our sample input. So remember, our sample input gave us the numbers 3, 40, 75, 50, 35, and 10, and 45. Now these first 3 lines are our segment lengths for the road and their specific speed limits. And the next 3 lines are our Bessie's segments and Bessie's speeds. So the first one would be 40 and 76. Second one is 20 and 30. And the last one is 40 and 40. So if we were to visualize this, suppose there is a road, and that road spans for 100 miles. Now, we want to separate this road into n segments. So the first 40%, and I'm just gonna estimate 40% here. First 40% will be speed limit of 75. The next 50 will have a speed limit of 35. And the final 10 miles will be 45. Now, all of these speeds are the speed limits. So, we'll draw a line, and to remember, these are the speed limits. So, if we gear back to Bessie's speeds, the first 40 miles, she will be going 76. The next 20 miles, she goes for about 30 miles per hour. And the next 40, she goes 40 miles per hour. And so, let's take a look at this. Before we do, let's just label it. So this is Bessie's speeds. And so she is going 1 mile over the speed limit here. So our current max for how much she's going over the speed limit is 1, because she's going 1 mile over the speed limit here. Now let's keep going, right? We're just driving through this road. You see 30, right? That's the next speed on Bessie's speed list. But 30 is actually under the speed limit of 35 here. So we'll keep going. Now she's driving 40. We look at the speed limit, and we notice that the speed limit is 35. So she's actually going 5 miles over the speed limit here. So we're going to cross this out, and now max is equal to 5 because she's driving 5 miles over the speed limit. Then we'll go to the next segment. Bessie's going to keep driving at 40 miles per hour, but we can see here that the speed limit has changed and is now 45. So at the end, we're driving actually under the speed limit. And so if you've done some USACO problems already, you could probably see where this is going. But if you haven't, what we're going to do here for our code is that we're going to create two arrays. The first array rather array lists. And so the first array list will be Bessie's speeds right here, and the second will be the speed limits. And what we'll do is we'll make each of these array lists have 100 elements, because the road is 100 miles long. So one element will represent 1 mile. And we're just going to check every single element and see how much Bessie is driving over the speed limit by, and we're going to update max accordingly. And so we're just going to check every single comparison, and eventually at the end, theoretically, we will have the max. So let's go ahead and do that. Okay, so this is our USACO template. If you don't have it, just feel free to pause the video and copy it down really quickly. So I'll give you a couple seconds. Okay, assuming that you're back, we'll start. And so first we'll just clean some things up. We're going to be using buffered reader. So we're just going to allow our code to use that. The problem itself is going to use file input and output. So we're going to be reading from speeding.in and writing to speeding.out. Okay, so now that we have our code set up, let's create our variables that we're going to need. So we need two integers, n and m, as shown in the problem. And we're going to need two array lists, as I said before. And these array lists are going to store the Bessie's actual speed and the speed limit for the sections of the road. So now that we have these two or these four variables, we'll go ahead and we'll initialize them. And so n will be equal to the first line, first variable, and m will be equal to the very next one. If you don't know already, a string tokenizer is just a neat little variable that we can use to read in lines of file input and separate them via strings, via spaces. Sorry. And so, because these inputs are separated with spaces, we will read in n first and then m. Now let's initialize and read in our two array lists. So we're first going to read in limit, and this array list is going to store the speed limits of the 100-mile road, and speed is going to store the actual speed that Bessie is going at. We will also have integers a and b. These are just going to be keeping track of the speeds and the segment lengths given in our input. And so let's go ahead and fill those array lists up. So first, we're going to be filling up the limit array list. And so we're going to be looping all the way from I equals 0 all the way to n. And in the array list, we're going to have st, which is our string tokenizer, and it's going to take in another line, and then it's going to read from that line and set values equal to values in the string tokenizer. So a will be equal to the first value gotten from the string tokenizer. This is because, if you recall, in our inputs, the first thing given to us is our road length. And so a is going to be equal to that length, and b is going to be equal to the set speed limit of that length. And now we're going to set values in the array list. So if it wasn't clear before, the array list plan that we have is we're going to have an array list with 100 elements, and for the next a elements, all of those a elements are going to be equal to b. So you'll see what I mean. So we're going to do int j equals 0. J is less than a, right? Because a is the length of the segment that we're focusing on right now. And we're just going to add b, because b is the speed limit. Now, it's essentially the same process for the speed array list, except, of course, we're going to be adding it to the speed array list, not the limit array list. And so that's pretty much our initialization step. So what this just does is it adds the designated speed limit to the next segment length variables. So for example, if we had a segment of 40 miles and that segment's speed limit is 75 degrees, we're going to have 40 elements with the value 75 in them. So I hope that makes sense. And now we're going to get to solving. And so in order to help you guys visualize what those array lists might look like, let's just quickly go ahead and print them out. and then we'll print the next one. And so first we need to give our inputs, but we have to change that to scanner. So now we're gonna move on to our solve part of the problem. And so the solve part is pretty simple. All we're gonna do is we're gonna make that max variable we were talking about during the illustration, and that max variable will just store the maximum amount that Bessie goes over the speed limit. And now we're gonna compare through every single pair in the array list, in both array lists, sorry. And it doesn't really matter which array list you use in the length of the for loop, because they're both 100. So now we're going to check if the current value at speed minus the current value at limit is greater than max, then max is now equal to speed, this current value at speed minus the current value at limit. And after that, we're just going to print out max. And one correction actually that needs to be made, sorry for not addressing that, but this actually needs to be m. The reason for this is, in our test case, n and m were the same number, but in some other cases in the problem, that might not be true. And so always remember that the first n lines is the given speed and segment length, and the next m lines, which can be different from n, is Bessie's actual speed and Bessie's segment lengths. So now let's go ahead and submit the problem. And we'll submit that. And as you can see, we passed all the test cases. So that's about it, and thank you for watching.